use the fusion reaction to generate electricity directly rather than going through heat and sort of spinning turbines with steam.
And then once you get to engineering break even, you have to go beyond that. You have to get to commercial break even, really have something that's economically viable. And that's probably another factor of 3.
So Google's not going to go away, but people are putting search terms into AI and coming back with these results.
The price of Bitcoin rises as the 5.8 power of time. And then these bubbles that appear on top of it and add more volatility and noise. And we've been able to separate those out.
Welcome to the Orion X Download Podcast. Join Shaheen Khan, the Orion X analysts, and special guests as they discuss and simplify the big ideas in technology that are changing the world. Thank you for being with us.
Hi, everybody. Welcome to another episode of the Orion X Download Podcast. This one is really special because we've got all the Orion X analysts in one place. As you all know, we have an interdisciplinary approach to advances in technology and their impact on markets and policies. And that allows us to track a lot of the major trends in the market, from IoT to 5G to cryptocurrencies, quantum computing, on and on. Now, we have internal meetings regularly when we kick around all of these ideas. This is an attempt to record one of them and bring some of that internal discussion to you. So hopefully it'll be well received and it'll become a regular thing. So with me is Adrian Cockcroft, Chris Krull, and Stephen Perrineau. Thank you guys for being here. How are you?
Doing
Hi,
fine.
thank you.
All right. So without further ado, let's start with the topic that's on the front windshield of everybody, and that's AI. And maybe a good place to start is the DeepSeek phenomenon that happened a few weeks ago. It caused a major drop in valuation for a bunch of stocks, something like a $600 billion impact across multiple companies, mostly NVIDIA. And I think at this point, it's starting to shake itself out. And let's chat about that. Who's got an opinion on it?
I think the sort of world divided into people that thought that this was going to reduce demand for AI and people that pointed at Jevons paradox and said, but every time you make something cheaper, we end up consuming more of it. And I'm in that camp. So I think that we had an excess of demand over supply. There were waiting lists, and GPUs are expensive because they're in short supply. And making usage of that more efficient by an order of magnitude or whatever is just helping the market get things that wouldn't be economic to build more quickly and get to market at a better price point. So that's sort of my take on it. I think that the stock market crash was overdone, and I think it's going to generally increase the market and accelerate things over the medium term, at least.
Yeah, NVIDIA was saying yesterday that AI now needs to do like 1,000 times more computation than when ChatGPT first came out. That all of these advances in optimization of the software is a good thing, but it's going to simply allow you to do something that you couldn't even with massive infrastructure.
Yeah, and I think this isn't the only time that we've had like an order of magnitude improvement in efficiency effectively. They happen occasionally. So what's happening with AI capabilities is they aren't just gradually getting a little bit better every week, like you were turning up the clock rate on a CPU or something. It's happening in jumps where some new technique comes out and somebody says, oh, I figured out how to do this, and this new way of doing it is way better than the previous way, and then everyone figures out how to adopt that. So I think the rest of the market will copy what DeepSeek did, or pieces of it, and they'll all sort of settle on that as the new baseline, and then there'll be another one of these soon. I think the difference was maybe it was something to do with the way the timing and the fact that it was an unknown company out of China made it a story, and then everybody just over-indexed on this one story. I think there's a whole series of these improvements that are stacked up over time.
So the other thing I want to mention is that when you look at OpenAI and Google and XAI and some of these mega players, Meta, these guys are trying to build AGI. They're not trying to serve some application in some enterprise company and just leave it at that. So those guys are going to be in their own class, basically. But as it relates to enterprise adoption of AI, I do sense that one of these days, like in this year, they're going to say, where's the beef? And when we talk about where the beef is, I know that As you guys have personal experience, and Adrian yourself with the MeGPT project that you started. So give us a little bit of what it looks like on the ground as you actually use it. And where does it work? Where does it not work? Steve, you want to go first on that, since I know you've been doing a bunch of software development and that seems to be a very ripe area.
Well, I've been using it for coding algorithms for doing statistical analysis of, Bitcoin's power law behavior and things like Hurst exponents, which you use to determine whether something is strongly trending or mean reverting or random walk. And I've found it very efficient at generating code. You have to manage it. It does make plenty of mistakes, but it's like a high quality intern, I would say. Junior, senior, undergraduate kind of level. Responsive, but sometimes clueless. So it will often repeat the same mistake over and over and try to slip it past you, And so you kind of have to catch it and say, no, that's not what I meant. Do this. Forget about that. Do this. So my watchword is manage AI or it will manage you.
Yeah.
But I've found that it has been a productivity boost for this kind of activity by much more than a factor of 10.
It's interesting, Steve. I use AI mostly on the content side of things, but also doing some strategic planning and so forth. And I too use the term intern or 1,000 interns, but you have to treat the results as a work product of an intern. You really need to be diligent about it. And if you're just copy pasting, you're going to set yourself up for some issues. It's not always correct. But I find that as I build these little bots inside of ChatGPT to perform certain tasks, I'm personally challenged by the boundaries of my thinking because it is so much more capable than you initially approach it. So powerful tool, but yes, the watchword is take care to be the overseer of the product.
Adrian, where is your MeGPT project? That was really novel and very interesting.
Yeah, I've been working on that. I haven't done a push to the repo recently, so most of what's there is a little stale right now, but I'm aiming to get this done. My deadline is NVIDIA GTC. I want to have this thing up and running. So the idea was that I have generated an immense amount of content over the last few decades, presentations, videos, like in the sort of hundreds of podcasts and some books and things like that, articles, stories in various outlets. And I wanted to put all that into a persona-based LLM, which is basically a RAG model, so that it points back at the various sources you ask, and then you could ask it a question, and I'd give you that answer, because I've had many of these questions many times. I've got most of the text-based content figured out. The thing I haven't done yet is the podcasts, where there's a lot of Q&A, and that Q&A is very valuable input, but you have to sort of process it and figure out who's talking and things like that. It's all doable. Mostly I'm just tinkering with this in my spare time. I think what's happening in general in developer augmented, or AI augmented development, some of the more professional developers are having more mixed results. They're seeing sort of bad code and things like that. If you just sort of look around the repos of what's happening in the open source space, people are using AI to generate commits and try to sort of generate their reputation effectively, sort of that reputation stuffing, whatever you want to call it. And a lot of them are poor quality. So I think the other thing comes down to how well you use a tool matters, right? This is a very powerful tool. You can misuse it. There's a lot of bad quality AI generated code out there. And what I think is that it really enables test-driven development. The first thing you do when you're trying to create AI-based software is that first make me the test harness, make me the input data set to the test, make me the output, and then you can say, well, build code that solves this problem. And you have to think through what you're trying to do and have a good spec for it. But that, I think, is the right approach. And people generally didn't do test-driven development because it was too much hassle to generate the tests. They just wrote the code, thinking it through. So I think that that's the right approach for it.
Yeah, I love the idea of having a digital twin of Adrian
We all do,
and
yes.
having access to everything. And your digital twin is going to remember everything, probably even better than you do.
Yeah, and I can't remember when I said something, and it was in that talk back then, right? And there occasionally I get quotes. I've said a few things that got quoted over the years. The tool I'm using right now is called Supra, SOOPRA.ai, and they have a business based around building these AI personas for college lecturers and experts in various domains. So that's quite an interesting model. And the way that you can interface to it is just build a Google Drive full of all of your content and give them the link to the drive, and they'll munch through it all. But if you've got just a few things, then they've got like a web-based UI for putting a few bits of data in. So that's what I'm playing around with in my kind of quote spare time.
And what Adrian's doing is happening in the marketing world to a little different degree, but perhaps every bit as important in that I think it was Gartner said something like 25% of Google search activity will be displaced by AI and agentic AI, even as soon as next year. So Google's not going to go away, but people are putting search terms into AI and coming back with these results that we've talked about, where sometimes they're on the mark, sometimes not. But long form content is something we need to be thinking about, because think about the way that LLMs work. For you to appear in a search that's happening in ChatGPT or Perplexity or any of the others, you want to have content that gets embedded in the LLMs. And this blur between personal, I want permanent memory and a great search index for my stuff, and other work that you're trying to do is pretty important.
Yeah, it's a very evolving and complicated thing. But one advice we just talked about AI versus search or AI plus search in the marketing podcast that I do with Doug Garnett. And our take was that it's not quite there yet, as you mentioned, because it doesn't quite understand your prompt always. It doesn't give it to you in the format and brevity that you need. But it's also true that it's coming. And what companies need to do is to make sure that they're findable within AI when they need to. So it's not search engine optimization, it's AI chatbot optimization.
Exactly.
How do I put my blog out there so that it makes its way into? But then there's also ethical considerations, like if I'm answering your question, there's a fine line between the answer and advertisement. And are you going to charge for that? And it's all kind of becomes a bit hairy. So we'll see where it goes.
I think that if you look back at when we first started building websites, they were for humans to read. And then a bit later on, the robots were the target, right? And
Yes.
search engine optimization became the thing. And that's what you're building your website for. If it's not indexed, then the humans won't find it. And I think there's the similar aspect of this with content and trying to figure out, and maybe this is a business model for the OpenAI Perplexity people. It's like, we will index your content if you pay us to do that in some way. And then that generates traffic to you as the answer to that canonical answer to that question that they keep getting.
That's right on. Plus, they also want to go after rich media and help with the generation of videos and images and such. And all of that is coming as well. And companies are using AI to generate videos faster, including the voiceover, etc. But the challenge there becomes rights management. What rights, who has on what, for how long? And I think when you get into professional content creation, like let's say Hollywood or the music industry, that becomes something that requires a legal framework that is airtight now, and I'm not sure it exists yet.
That's a good sort of segue in that I was on CNBC on the, what was it, the 24th of February. They posted a video, but this wasn't an AI generated thing. I actually went up to San Francisco and sat in the studio and was filmed for an hour or so, and then they cut bits of that out and used it in this story about AI. And about the energy use of AI, but it was still done the very old manual way with real journalists chatting to people in person. And I think the other thing to tie into this is the NVIDIA's results came out, and they were talking about Blackwell shipments and 100,000 GPUs as a single installation kind of scale, which is that's a lot of they're like a kilowatt each or so. So that's a lot of kilowatts. That's 100 megawatts of just the GPU, not including anything else around it. So we're seeing a big rollout. All the big cloud providers have been saying that they've got huge capital investment money for doing this. So there's some big data centers being built, particularly for the training and for the general AI kind of space. And the question is, where does the power come from? Where do you put these buildings? You can't sit them next to the existing buildings in Dublin or Virginia because the power grid can't take it. We're out of capacity.
Yeah, well, that's a good segue into that. So all this AI stuff has presented a big problem. And where do I provision power? How do I transmit it to the data center? How do I extract the heat that they generate? And how do I transmit that outside of the building? So let's talk about this segment that you had at CNBC. It was a great segment, by the way.
Yeah. So CNBC have been looking at alternative power sources. Jordan Novett wrote the story, and Katie Tarasov was the on-screen interviewer that I was talking to. And the story was called "Soaring AI Power Demand Has Google, Microsoft, and Amazon Scrambling for More Energy Sources." It was interesting to see what the various things they were coming up with. A few different areas. One of them, Steve's a big expert in as well, which is around nuclear power in various forms. And what we've been seeing recently is some of the mothballed nuclear reactors or reactors which were going to be shut down have got a new lease of life. One of them is like a gigawatt level nuclear reactor that Amazon has just basically bought all its output. They're building a data center right on the same campus as the reactor. Microsoft is restarting one of the 3 Mile Island reactors that was previously mothballed. So that's the sort of really short term. We can use the nuclear as a base load for power stations. And then people are looking at, well, how do we build nuclear support? And then we start looking at things that are 5-10 years out. And it sort of goes in a sequence. One is we can just build more nuclear reactors of the same type that we have before. They're really big. They're quite hard to get planning permission for, lots of NIMBY issues. So then there's this idea of small modular reactors, and they go through the whole gamut from just basically a slimmed down version of the old style gas-cooled reactors, a fission reactor. You put in uranium and you get out a spent fuel rod. You still have to manage that. And then the next idea is fast breeder reactors, which have been in use in France in particular for a while. But it takes the fuel from the fission reactors, which still has lots of energy in it, and reuses those spent fuel rods as its input. So they kind of build a nice pipeline for that. There are some companies working on doing that. And then there's people looking at fusion reactors, which are the energy that powers the sun. Very difficult to manage the temperatures and containment that's needed there. And there's a few different approaches there. One of them that's interesting, though, is from Helion, who use the fusion reaction to generate electricity directly rather than going through heat and sort of spinning turbines with steam. They can extract energy directly from it. And maybe, Steve, you could talk a bit about what that looks like and the prospects for that being a plausible way of generating energy in the foreseeable future.
Well, the Helion design is a hybrid between a particle accelerator and the traditional magnetic confinement torus type designs. Most of the large national and international government funded efforts historically are these tokamak designs, and they use deuterium and tritium as a fuel. Deuterium being heavy hydrogen, tritium being very heavy hydrogen. One of the problems is tritium's extremely scarce, and so you have to breathe it. Helion is targeting helium-3, so they're going to use deuterium on helium-3. It produces a little more energy than you get in a deuterium-tritium reaction. It also requires higher temperatures, but they can produce their own helium-3 fuel. Helium-3 is a radioactive isotope of helium-4 with one less neutron. And since it's radioactive, you have to produce the fuel, and they can produce it through an much easier reaction, which is deuterium on deuterium. But the main thing that's different here is this fusion of that's a bit of a pun, of the accelerator design with the magnetic confinement. And if you do that, you're actually creating the magnetic field through the accelerator process. And that magnetic field that you create then confines the plasma, but also is used to induce electricity in wires externally. So they have two plasma toroids at either end. They smash those together, and they don't have to heat water to drive a steam turbine. And it also allows them to have smaller devices and higher efficiency. One other interesting approach is another fuel, which is boron. And there's one outfit in Southern California that's looking at that. They've had awards from DOE. They're called TAE Technologies. And there's another one in Australia that's looking at boron called, name of that company is HB11 Energy. So we've seen with the commercial designs that people are starting to explore, other possibilities. And that's a good thing. One of the things to keep in mind about when you hear about break even, scientific break even, as we first had at Livermore Labs with the laser confinement design. And recently the French have had a nice demonstration where they were able to sustain for 22 minutes. They talk about scientific break even, but that is a factor of 10 to 100 short of engineering break even. The one at Livermore, they were only counting the actual power that the lasers were putting out, but the power that had to be input to pump the lasers is 2 orders of magnitude higher. And even with magnetic fusion tokamak designs, it's probably at least an order of magnitude higher. And then once you get to engineering break even, you have to go beyond that. You have to get to commercial break even, really have something that's economically viable. And that's probably another factor of 3. So, we're 5 to 10 years out probably on engineering break even, which will be prototype designs, that are government subsidized and will be productive and will start to deploy and generate electricity, but they won't be money making. So it'll be hard to scale. It's going to take really decades to scale, both commercially and in volume.
Yeah, I think Helion is saying that they should have their prototype up in 2029, about 4 years from now, but all of these things tend to run late, and there's this whole area of first of a kind. So some of these things, like the small scale fission reactors, very little risk in that. As you get further down the line, you're getting higher and higher risk, and we're seeing that also with hydrogen fuel cells. There's a company that they were talking to in this video that's promoting that. But again, it's very small scale. It depends on green hydrogen being available. And green hydrogen is pretty much by spare electricity. But if you've got spare electricity, it makes much more sense to put it in a battery and then take it back out of the battery, because that round trip is between 85 and 98% efficient, depending on whether you're going across the grid to get to the batteries or not. And then if you take that electricity, turn it into hydrogen and then ship the hydrogen and use the hydrogen somewhere else, that's only roughly 30% efficient. So you lose a lot of the energy. Effectively, you've got free energy during the day from the other fusion reactor that we already have called the sun. That's generating solar all day, which we have too much of. So then you take that solar, you either put in batteries or you use it to generate hydrogen. That's the two main uses of it. The other one that's interesting in this space is Fervo, who have they're quite along the way, geothermal to work using the techniques that have been used for fracking. So they're doing a modern take on geothermal. They've got a prototype reactor that's been up for almost a year, and they're scaling up. So the other thing, as Stephen mentioned, there's government support for this, but the new administration is really doubling down on oil and gas and maybe hydrogen, because the oil and gas companies like putting things in pipes and they can kind of get hydrogen out of the gas. But the federal loan program that was designed to de-risk all of the first of a kind of these new energy sources is basically being shut down. The guy that was running it's left. It's not at all clear if that's happening. So what was the government's position was they were going to de-risk the first of a kind. They're now effectively creating extra risk for first of a kind. So it remains to be seen if those investments survive the various cuts and randomness that's happening now. So there were a few comments in the video about that uncertainty being a big issue.
Adrian, you were also talking about the Green Software Foundation.
Yeah, that's sort of the other aspect of it. My qualifications for worrying about sustainability, energy, and things like that is that the last role I had at Amazon was a VP in the sustainability organization. And since I left Amazon a few years ago, I've been running a group at the Green Software Foundation, a project called Real-Time Cloud, where we are gathering all the data from the different cloud providers and what they have for power usage efficiency, their carbon footprint, their different sources, how much carbon-free energy they generate. And we've been done that up to now. We've been publishing data for Amazon, Google, and Microsoft. And I've just started investigating the Oracle Cloud, and they have quite a few regions around the world, and they publish data. Each of these, the data is sort of a bit hidden. You have to rummage around and find it. And what we're doing is putting it in like a centrally accessible table of results and publishing that information. So you can go look at it's all on GitHub. It's all open source. You can go look at the Green Software Foundation real-time cloud project. If you're looking for my MeGPT thing, it's under AdrianCO/MeGPT on GitHub. Generally, I'm working on open source stuff nowadays.
So, Steve, I love the gradation that was in your response, going from science to engineering to commercial. I can sort of envision a 3x3 graph because that's what analyst firms do, where that's on one axis, and then whether you have a demo or a kernel or a full app on the y-axis, and then you can track the quote-unquote realness of these advanced technologies. But that also raises the question of how do you communicate about these things. And Chris, you mentioned something about communication in our pre-call. I don't remember now whether it was in association with AI or in general, but that's definitely a challenge in society too right now.
Absolutely. And, I got to thinking the other day, and actually this is around, I think I'm on the biggest sports fan on the team here. So that kind of biases and warps my thinking a little bit. But
not exactly a big achievement, but yes.
Until you get the Formula One season's just starting, so my sports fanning is like purely focused on that one thing. But anyway.
Fair enough. I will say that I'm probably the biggest NFL, National Football League fan on the team here. But about 2.5 weeks ago, the Super Bowl was happening, and I don't know if you folks remember this or realize this, but Super Bowl was always the big venue for new ads, right? It was as much an event to watch the ads come out as it was to actually watch the game.
Yes.
But I was thinking about this in the context of the repetition that messaging needs to have before it starts sinking in. I mean, it's one thing if you hear a message around NVIDIA or Apple or anything that we're already carrying a lot of information about in our heads. It's a lot easier to hang something new onto that framework than it is to try and penetrate it. So I actually sat down with my laptop and whipped out an Excel spreadsheet, and I logged every commercial that appeared there. And there's this axiom in the advertising world and the marketing world about needing to hear a message 7 times before it starts thinking it. I've always thought that was way undercounted, and especially now, right? I mean, we've been for decades now, we've been just besieged.
It has increased. I think I saw some research that said it has, even the research was saying it has increased by like a couple of factors.
Oh, it has to be easily.
Yeah.
So I, and back in the .com era, we all made fun of the companies that clearly spent all of their marketing budget and then some on just a quick 15 or 30 second spot. Today, those 30-second spots go for $8 million. And you think about, how you spend your money. There were only a handful of companies who I had never heard of that did a one-off ad.
Really, the question for many of these ads is, do you remember whose ad it was?
I used to look forward to these ads. This year, I thought they were pretty meh. I was surprised because I watch football throughout the season. And one of the big takeaways is State Farm does all of these insurance commercials, right? And Progressive as well. Okay, throw Allstate in there. Those are the advertisers I remember. And not a single insurance ad was shown during the Super Bowl, which shocked me. But anyway, coming back to the point about communication and frequency thereof, we just have so many more channels today. My daughter pointed out to me that, well, look, I've seen a bunch of these ads already because they've flooded YouTube with them. So we're not waiting for that one day to roll out a new ad. But, the marketeer's challenge is much harder today because we have so many more channels we need to take care of.
Very much so. And I think referencing our conversation on AI, I also note that the audience is getting trained to expect exaggeration. And therefore, many messages are viewed as entertaining rather than seriously. And to break through that is really difficult. And of course, what we said, I mean, this is what we do as a firm. There are so many important trends in the market that to put your arms around all of it is just like really hard,
Yeah. Oh, for sure. For sure.
Yeah.
And you think, so if we start thinking about the MarTech marketing technology stack, There's this firm that tracks these things, and they started looking at the MarTech apps, or they went back and cataloged the MarTech apps from 2011 and through 2024. They considered that in 2011, there were 150 apps that they considered part of the MarTech stack. And these would be things like your, Salesforce is around, so Salesforce CRM, that sort of thing. Today, they log over 14,000 apps, and full third of those are content marketing related. And even though the big guns, the Adobes and the HubSpots and the Microsoft, Salesforce, et cetera, have been adding AI capability, there's just so many more small tools that are coming on. And this ties back to the work that Adrian and Steve do in coding. It's a lot easier to develop an AI-based app today than it ever was. I suspect we're just going to see that trend continue.
And put a wrapper around ChatGPT or Anthropic or whatnot.
Yeah. Alluded to this earlier in our conversation today. We're also observing that these focused medium language models, small language models are taking place where they're much more focused on your particular industry or your particular challenge.
That's right. So let's do quantum computing. Steve, I'm going to come to you for this one. This past week, we saw Microsoft finally unveiling their topological qubit quantum processing unit, QPU, Majorana 1. What was your take on that?
Well, certainly the hype was pretty heavy. We're talking a handful of qubits. I think it's 8, right?
That's correct.
And it's very interesting technology. There's a lot of skepticism about, and this is from the quantum physics community, the hardcore, not the engineering side, saying that they're not sure that these guys have actually produced Majorana states. So there's that. These are like people may have heard of phonons, which are like these virtual sound, in materials. This is something where you have, again, obviously very cold temperatures, and you've got, superconducting going on, and you've got a nanowire, and then you're inducing somehow these Majorana states in there, and then you have to entangle them. And if you can induce those and then entangle them, and then you can start to build up gates, that's the path that they're on. But there's a fair amount of skepticism. And the hype really was that they've mapped out to 1 million qubits. They're saying that's their road,
Right.
And some of the better analysts like Bob Suter are saying, well, tell me what you've really done or what you can do in the next year. We're getting a little tired of hearing about the 1 million qubit roadmaps. The reason why everybody's on these 1 million qubit roadmaps is because that's been kind of the generic target of, if you want to get to 1,000 or so logical qubits in order to run Shor's algorithm and break cryptography, you're going to need, something like 1 million qubits. Now, there have been some advances lately, potentially with the Willow chip from Google, potentially with this one, and some other approaches where, we're getting better maybe at noise correction, but none of this is proven. All the scaling is happening right now is relatively small physical qubit counts of order 1,000 or less, and then error correction that reduces to a handful. Willow was using all of their real estate to essentially get 1 qubit, or maybe 3, with some error correction. So we're in this noisy intermediate state, and, they're trying to get into the next level or next phase with better error correction and fault tolerance, but we still haven't reached what you, Shaheen, like to call the transistor moment.
Yes, I've heard other people use it, so maybe it's like an industry term that everybody simultaneously came up with. But yeah, and as I like to say, we're not even to the VHS Betamax moment either. No technology has won that's going to rally investment behind it and make rapid progress like transistors did. And we may not get that. In fact, there's appetite in the quantum computing world for additional modalities. But for Microsoft to make advances in topological really is scientifically very interesting, but not engineeringly, as you mentioned.
Yeah, I think that's where we are. It's, a little bit like in the fusion space, if you demonstrate some scientific break even with a laser, but nobody's building that design in an engineering way for actual fusion machines, and it's far short of engineering proof. So that's
Yeah.
kind of where we are, but we commend all of their activities and efforts, and there's many different approaches. There are half a dozen kinds of models, a lot that require superconducting Josephson junction type as their basis, but others that use ions or neutral atoms in very highly excited states or photonics. And these are all vying for advantage right now.
They're all valid approaches. Now, one interesting thing about the Microsoft chip is that the chip itself is fabricated all in-house at Microsoft Labs. And because it requires semiconductors as well as superconductors, and it uses non-standard materials like
Arsenide.
indium arsenide and other materials like that, the simulation software isn't available, so they had to do that in-house. And it's good that they had ready access to Azure resources, HPC resources, to do that simulation. But it's also fabricated in-house, which is really interesting. That's further evidence of the market just being in its infancy, where the supply chains are just developing and it's all kind of at the small volume prototype stage. But it is promising, and they're eligible to go find out what exactly they have achieved. And it was promising enough to get them a spot with the DARPA quantum benchmarking initiative that they have, Microsoft as well as PsiQuantum, that has a silicon photonics approach. Both got that, and they both espouse that this is the way to get to 1 million qubits on one chip, not having to cluster multiple chips together. All right, shall we move to Bitcoin and cryptocurrencies? Steve, I know you do the Physics of Bitcoin podcast with Giovanni. Both of you guys and a couple of others have been pioneering the application of mathematical modeling to Bitcoin behavior. So catch us up if you would.
All right. We do those shows live every Wednesday, U.S. time, 7:15 p.m. on the West Coast, 10:15 p.m. on the East Coast. I'm in Asia, so it's Thursday morning my time for the Asian audience. And the Europeans are probably not fitting out so well. But we've had 11 shows so far on this weekly schedule. And the sort of fundamental physics that underlies Bitcoin is we perceive it, and as was first elucidated by Giovanni a decade ago, is the power law nature. And we've actually got a combination of Metcalfe's law and to some extent Moore's law, both working together in Bitcoin. But the primary thing is the network effect that you have with Metcalfe's law, which is something like the value goes roughly as the square of the number of connected nodes. So in this case, it would be users or wallets and so forth, and you can track that. And historically, that's grown as something like the cube of time. So that already is very rapid. And then if the value goes as a square, you have something close to the sixth power. And we've validated over the history now of Bitcoin that started in January of 2009 and is now a little over 16 years old, that it sort of oscillated around like an engine starting up the first few years, but then it's locked into this power law pretty nicely. And it's been on a trajectory where the power law index hasn't really changed much at all. Within statistical measures, it's been about 5.8. So the price of Bitcoin rises as the 5.8 power of time. Now you see all these bubbles. And so one of the things we do is we try and sort out the core power law behavior and then these bubbles that appear on top of it and add more volatility and noise. And we've been able to separate those out and show. In fact, you can take the logarithms of the price and run the power law through, and you find that you get a dual Gaussian. So you get a lower Gaussian that describes the power law core, and then you get an upper Gaussian that describes these bubbles. And so that's quite nice that we can separate those, and those are quite clean. Recently, we've been talking about the Hurst exponent, and we presented that today. This is another statistical technique that uses a scaled range. It was first invented by a British hydrologist and published a long, long time ago. He was studying the Nile River and reservoirs and so forth and carrying capacity. And so he developed this technique, which is you look at all the many years and you look at all the partial sums, and that gives you a range, and then you normalize it by standard deviations. And you find out that if you use different window sizes for your duration, that's a power law, and it's a power law to an exponent h, and h is the Hurst exponent, and that's typically between 0 and 1. And when it's 0.5, you've got a random walk. And when it's close to 0, you've got strong mean reversion. And as it gets up close to 1, you've got persistence and very strong trending. And what I've just demonstrated is that the way people have been doing it in the past has been inadequate, because they've been analyzing to find the Hurst exponent, but they've just been running moving averages through it. They didn't have awareness of the power law, and they find an Hurst exponent of about 0.6, which is, trending. It's nice. It's better than you get with, say, emerging market stocks, but it's not rip roaring. But if you take the power law and run the best fit power law through, and then take those residuals and then do this analysis for this Hurst exponent, the answer is 0.9. So it's an extremely strong trend. And if you want to see more about that, you can go look at one of these shows. They're up on YouTube, and then we run them live on both X and YouTube, at those times that I gave. Wednesday, 10:15 Eastern.
Right on. All right. So maybe we can wrap at this point. We have GTC coming up. Our next show will be after that. One big aspect there, of course, is the fabrication technology and what TSMC is doing in the US and what they're doing in Taiwan, and what's happening to the leading edge fab technology with Intel doing their 18A and 14A fabs in the US, and TSMC doing kind of an N-1 to N-2 fabs in Arizona, and Samsung kind of trailing behind the two, but being in there. That's all a matter of giant geopolitics that we should double click into, and is going to give us an opportunity to talk a lot about chips and GPUs and accelerators and ASICs and FPGA.
And how to keep them cool, because we're looking at the next generation. What we're hearing about Rubin is like doubling or tripling the power per rack into the hundreds of kilowatts.
I hear that too. Last year, they announced a rack that was 120, 125 kilowatts per rack. This year, I hear that you're liable to get over 300 kilowatts per rack, on its way to something like 800 kilowatts per rack. So the era of a megawatt per rack is approaching. But of course, the idea is that it does a lot more. So you actually, and in aggregate, you're going to need a lot less of it to do the same thing.
I think you can use it as a light source at some point. It's a lot of energy going into a small space. So anyway, there's going to be some interesting things. I'm going to be at GTC. Last year and this year, I went on a press pass, and I wrote a story for the new stack.io that's for that online journal. And I'll be doing another one this time. I've done a few blog posts around it as well, but I'll be basically looking to update what I saw from last year and how it's developed for this year. And looking into the benchmark claims that they made, I kind of tried to deconstruct the benchmarking, if you like, of how they got to their claims last time.
Yeah, they just announced massive numbers with DeepSeek on Blackwell as well, like 20 times better than before, sort of a thing. But it looks like the era of rotisserie chips are coming. So we might get fed at the same time. All right, everybody. Thanks for being with us. Any questions, comments, please let us know. We're delighted to have you. And until next time, take care. Thank you, gentlemen. I look forward to the next episode.
Yes.
Okay, thanks all.
That's it for this episode of the OrionX Download Podcast. Every episode is posted to orionx.net and shared on social media. Use the comment section or tweet us with any questions or proposed topics of discussion. If you like the show, rate, review, and share it. The OrionX Download Podcast is a production of OrionX. Thank you for listening.